Acceleration is the rate of change of velocity. It is a vector quantity, meaning it contains both magnitude and direction. The average acceleration of an object can be calculated using A is equal to delta V over delta t, or the change in velocity over time taken. A is in meters per second squared, the change in velocity is meters per second, and t is in seconds. Now, the change in velocity is the difference between the initial and final velocity, where it is the final versus the minus the initial velocity. Instantaneous acceleration is the velocity of an object at any given point in time. Now, to find it on a velocity time graph, first draw a tangent at the required time, then calculate the gradient of that tangent. This is similar to how you calculate instantaneous speed or velocity. Let's do this worked example to get a better understanding of the concept. A car decelerates at a constant rate in a straight line. The velocity of the car decreases from 50 meters per second to 25 meters per second in 10 seconds. A. Calculate the change in velocity of the car. So the change in velocity is equal to v minus u. So here, u is equal to 50 meters per second, while v is equal to 25 meters per second. So we can plug that into the formula, and we have 25 minus 50, which is equal to negative 25 meters per second. Now, to calculate the acceleration, we know that the formula is A is equal to delta V over delta T. So we can plug that in. So negative 25 over 10, which is equal to negative 2.5 meters per second squared. Now, it also said in question B, it says calculate the acceleration of the car and state if the car is accelerating or decelerating. Now, since the answer is negative, we know that the car is decelerating.